Sketch a function with the features described below. So f of x is 0, in other words we have x-intercepts when x is -1 and x is 1. Now the gradient is positive everywhere from x is 0.5 onwards, and it's negative from 0.5 backwards. So that suggests to me that we would have a turning point at 0.5. Now since the gradient is positive after 0.5 and negative below 0.5, it's got to be a minimum sort of here. The other turning point when x is 3, that's got to be a horizontal point of inflection. The reason for that is we know the gradient is positive before and after it. So that suggests that it's got to come down through this intercept, have a turning point here, intercept here, and then it's going to go in towards this other turning point here. So it's going to do something like this. Now I'm not absolutely happy with the shape of the curve over here, so what I'm going to do is I'm just going to get rid of some of that, because it does say that the second differential is 0 when x is 2. Now that's not a turning point, but it tells us that we have to have the maximum gradient at this point. It's an oblique point of inflection. So the highest the gradient will get will be at 2. So let's have the curve so it's getting steeper all the way up here, and then it starts to curve in towards this point of inflection. Let's put that point of inflection just a bit further up. So maybe there, and then we can turn in towards that and then carry on upwards like that. So this would be the steepest part of the curve along here. We now want to state the values of x for which f of x is less than or equal to 0, in other words where the graph is below the axis, and therefore we can say that x is between -1 and 1. We can see the curve is below in that region.